This is question number 49 from book number 1 based on the 2020 NEC, and this is electricaltime.com. What is the minimum feeder standard size overcurrent protective device in amps operating at 120 volts single phase that will supply a lighting circuit of 24 amps and a separate circuit supplying power to utilization equipment at 20 amps? That is not a motor. The utilization equipment is powered up for a few minutes each hour. Okay, so what we're talking about here, we're talking about that overcurrent protective device, and we're talking about also that feeder as well. So, they're both correlated together. We have to make sure that that breaker, that overcurrent protective device, is protecting that feeder. Just want to take 30 seconds to let you know what we do here at electricaltime.com. We do online electrical classes from the comfort of your home. And then we also have this free service. So if you click on the subscribe for free NEC questions, Monday through Friday, you'll get an NEC code question and an answer sent to your email. All right, so back to our video. And the answer to this question is going to be A, and that's going to be a 50 amp breaker. So let's go into our code book and let's see how we found this. So the first question we're going to ask ourselves is, what article are we talking about? And that's going to be feeders. And feeders are found in Article 215. Right, and Article 215 for feeders is found in Chapter 2, Wiring and Protection. And once you're in 215, you are going to start to look for the parts, but there's no parts in 215, so we're just going to look at the sections. And then we find 215.2, and that's called minimum rating and size. Then we find 215.2a, which is called feeders not more than 1,000 volts. Then we find 215.2A1, general. Then we find 215.2A1A, and here they're talking about the continuous load at 125% and the non-continuous load. And also, we're talking about 215.3 for overcurrent protection. All right, so let's go take a look at our code book. Let's look at 215.2A1A. And, what they're talking about here, again, we're looking at the minimum rating and size. We're looking at the feeders not more than 1,000 volts, because in our question, we had specified that this was 120 volts. And what we're looking at here is A, under 215.2A1A. All right, I'll repeat that again, 215.2A1A. And what it says, when we have a feeder that supplies a continuous load or any combination of continuous and non-continuous loads, that the minimum feeder conductor must have an ampacity of not less than the continuous load plus 125% of the continuous load. So when I read this for the first time many, many years ago, I had no idea what they were talking about, but I'm going to simplify it. So when you see that, you take your continuous load and you're going to multiply that by 125%. And then if there's any load on that feeder that's not continuous, you're just going to take it at the load at 100%. All right, so I'll make a real easy example. So let's say you've got a continuous load of, let's say, 10 amps, and that's going to be a lighting circuit. And we know the lighting circuit's going to be on for 3 hours or more. So that portion of the load, 10 amps times 125% for a continuous load, is going to give us 12.5 amps. But then we have something else, and let's say it's 10 amps, but it's not a continuous load. So what we do now is we take that original 10 amps for the lighting times 1.25 for the continuous load. That gives us 12.5 amps. And then we add, the rest of it, which is not continuous, and that was going to be 10 amps. So I got 12.5 amps plus 10, and that's equal to 22.5 amps. And that's going to be the ampacity that's going to be on that feeder conductor. And then we have to size it appropriately. And we have to make sure that we size the breaker correctly as well. All right, so let's do this. Let's go into our textbook and let's see what we got. So step number 1, we need to size in amps the loads connected. Step 2, the lighting circuit is 24 amps at 120 volts. Since lighting loads are considered to be continuous loads because the lights will be on for 3 hours or more, we must multiply the 24 amps by 125%, which gives us 30 amps so far as the continuous load. All right, so now we got 30 amps. I know we started at 24, but 24 amps is going to be for that lighting, and that's considered to be a continuous load. We take the 24 amps times 125%, and that's giving us the 30 amps, which is our continuous load. Okay, step number 3. The piece of utilization equipment is 20 amps at 120 volts. So therefore, we only have 20 amps to consider in helping us to size this portion of our feeder overcurrent protective device. FYI, the piece of utilization equipment is not considered a continuous load since it is powered up for a few minutes each hour. It's very important that you identify what the loads are going to be on the feeder so that you know how to account for that. Are they continuous load, yes or no? If there's a continuous load, it's going to be at 125%, and then the rest of the loads obviously are not going to be continuous loads, and you're just going to take them at 100%. All right, so step number 4. 215.3 overcurrent protection for this feeder tells us that we need to size this breaker to at least 125% of the continuous load plus the non-continuous load, which comes out to be 50 amps. And we got that because we got our 30 amps. And remember, we had a lighting load of 24 amps, and we multiplied that by 125%, and we got 30 amps. Plus, we have that additional 20 amps, from steps 2 and 3 above. So step number 5, look at table 240.6a, which gives us the standard size breakers, and we see that 50 amps is a standard size breaker. Therefore, a 50 amp breaker would be the correct choice. So let's go take a look at table 240.6a together in our code book. And here it is. Also, I have a note here for the NFPA link, and I'd like you to go check that out when you have a chance. You just go to the NFPA's website, that's nfpa.org, and you get the code book on your phone. It's about $10 a month. It is really, really good. All right, so here is this table here, table 240.6a, and it is called the standard ampere rating for fuses and inverse time circuit breakers. And this is where we find our standard ampere ratings. So here we can see we've got 15, 20, 25, 30, 35, 40, 45, and there's our 50. All right, and that's the one that we want. We want the 50 amps, and that's going to be our answer. So let's say that when you did these calculations, you came out with like 49.1 amps. Is there such a breaker as 49.1 amps? And the answer is no, not according to this table. So then we would then go to that next size breaker. In this case, it'd be the 50 amps. So the answer to this question is going to be A, and that's going to be the 50 amp breaker. And this is code reference 215.3.